Welcome back to The Explainer. Today, we're diving into something that honestly sounds straight out of science fiction, but it is happening right now. We're talking about the incredibly high stakes, highly complex process of taking physical construction wood waste and converting it into highly verified digital carbon assets. Basically, we are building a digital twin of the physical world. It's an unbroken data trail powered entirely by next-generation AI that takes scrap wood, turns it into biochar, and eventually turns that into cash. And to really understand why this matters, we have to anchor this entire operation to one very specific financial reality: $350. Right now, a single ton of high-quality, verified carbon credits is selling for roughly $350 in the voluntary and compliance markets. So we're talking about a very serious financial asset here. But there's a catch. To actually capture that value, you have to prove, literally without a shadow of a doubt, that a specific ton of carbon has been permanently removed from the atmosphere. And to do that, you absolutely need a flawless, audit-proof system. Which brings us to the timing of all this. Industry insiders are actively calling 2026 a strategic hinge year for energy and AI. Some are even calling it the dawn of the SaaS apocalypse. What that means is traditional software, where humans sit down, log in, and manually click through spreadsheets and data, is becoming completely obsolete. It's actively being replaced by autonomous AI agents that are fully capable of managing these complex carbon pipelines and making split-second compliance decisions on the fly. So here's our agenda for today. We'll cover 1. The hinge year for AI. 2. The chain of custody. 3. The mass balance equation. 4. Defending the carbon yield. 5. AI regulatory agent teams. And finally, 6. The verification barrier.
All right, let's jump right into section 1, the hinge year for AI.
When we talk about this AI architecture, we aren't just talking about a single chatbot doing everything. We're looking at a highly specialized tech stack. You have Google Gemini 3 Pro acting as the eyes, ingesting visual data straight from demolition sites. Then, OpenAI's GPT 5.3 Codex is autonomously coding and debugging the backend infrastructure. Anthropic's Claude Opus 4.6 steps in essentially as your chief compliance officer. Perplexity acts as the verifier to prevent any made-up facts. And finally, a system called Grail generates the final polished reports. Put all that together, and it's like having a fully staffed automated corporate compliance department that literally never sleeps. Moving on to section 2, the chain of custody. So let's look at the physical reality. If you want to monetize waste diversion through carbon credits, you need an absolutely unbroken chain of custody across 3 crucial steps. First up, the point of origin. This means mandatory pre-demolition audits capturing the exact wood waste at a highly specific GPS location. Second is transportation. You have to track the haulers and calculate logistics emissions because those actually get subtracted from your final carbon benefit. And third, processing. Here's the kicker. If data goes missing at any single one of these stages, it instantly kills the carbon credit down the line. The digital twin has to be perfect.
Let's move into section 3, the mass balance equation.
Grounding this math in reality, processing facilities handling huge metal bins of processed biochar have to implement a mass balance accounting approach. It's a non-negotiable regulatory requirement under rules like the Clean Fuel Regulations. The equation itself is simple enough in theory. Your starting inventory plus any incoming material must perfectly match your outgoing material, plus whatever you have stored. Basically, what goes in must perfectly match what comes out. It's the only way to prevent double counting and prove that the volume of biochar corresponds exactly to the eligible wood waste you received. But here is where things get really contentious. There's a massive methodological dispute in the industry right now. A lot of theoretical models might claim a 0.75 yield factor on raw biomass, but physical audits of standard slow pyrolysis tell a different story. They show you generally only retain about 50% of the original carbon in the biochar. So how do you survive an audit with that gap? Advanced systems apply what's known as the Operon adjusted CORC formula. This imposes a strict 0.85 multiplier, basically an 85% haircut on those theoretical yields, bringing the math firmly in line with brutal physical reality. Which perfectly tees up section 4, defending the carbon yield. Because of that yield dispute, regulators demand hardcore scientific proof of permanence. First, the H to C org ratio. That's the ratio of hydrogen to organic carbon must be less than 0.7. If it's not, the material's just going to decompose. Second, if you're going after those ultra-valuable 1,000-year carbon removal claims, emerging standards require measuring something called random reflectance, which has to hit a value greater than 2%.
Tracking these exact lab measurements requires intense, dedicated infrastructure. That's exactly why future deployments point toward Phase 4.5, often known as the lab, using the Operon Scientific Workspace to securely manage all this complex chemical data.
Let's pivot back to the digital side. In Section 5, AI regulatory agent teams. How do we process all this scientific and logistical data? This is where the magic really happens. Anthropic's Claude Opus 4.6 is deployed as the regulatory compliance layer, and it features a massive 1 million token context window. To put that in perspective, it means it can hold incredibly dense, massive legal texts like the entirety of the Clean Fuel Regulations and the ISO 14064-3 standards in its memory, all at the same time. By deploying agent teams, the system literally simulates an internal auditing department. You've got one agent monitoring the incoming biochar lab data, another cross-referencing it against complex legal definitions, and a third actually drafting the audit report. Now, you might be wondering, doesn't AI hallucinate and make things up? Absolutely. And in regulatory reporting, a hallucination isn't just an error, it's fraud. That's exactly why this tech stack mandates hallucination prevention. They use a perplexity model council to run complex queries across multiple AI models simultaneously, essentially triangulating a consensus. Then, that tool Grail generates the final technical reports with 0% hallucination in its citations. If it can't explicitly verify a reference, it just leaves it out. It locks an absolute submission-ready accuracy. And that brings us to the final hurdle, Section 6, the verification barrier. Despite all of this incredible AI automation, Environment and Climate Change Canada mandates that ultimately an independent human verification body has to sign off. The AI builds the perfect case, generating robust, peer-reviewed evidence chains that supply the required documentation. But at the end of the day, human experts in life cycle assessment and financial accounting have to review those chains. They need to ensure the data provides a reasonable level of assurance that absolutely no material misstatements exist. And those human auditors, they are strict. They're looking for flawless adherence to key hurdles, ISO 14065 and 17029 accreditations, secure 10-year evidence storage, and an error margin firmly under 5%. Every single piece of data must achieve true SR&D defensibility. That means the scientific and empirical basis of your carbon yield has to be completely bulletproof, because the end goal here is earning an unqualified opinion from the auditor. Only applications with completely clean opinions get approved to generate those high-value credits. Which leaves us with a final provocative thought. The journey from physical scrap waste to a digital asset worth hundreds of dollars a ton is incredibly rigorous. The standard is absolute, undeniable scientific and logistical traceability. So looking at the autonomous capabilities of agentic AI and the unforgiving nature of these carbon audits, you really have to ask yourself, is your data infrastructure truly SR&D defensible? Is it ready to survive an AI-audited, multi-million-dollar regulatory interrogation? Thank you so much for joining me to unpack this explainer. Keep learning, and I'll see you next time.